The Snieznik Small Arms Practice and Training System. The Snieznik Small Arms Practice and Training System was developed by the Military Institute of Armament Technology in Zielonka and the company Autocomp Management in Szczecin, and is manufactured to meet an order submitted by the Polish Ministry of Defense. In 2005, this system won the Grand Prix and Defender Award at the 13th International Defense Industry Exhibition in Kielce. General information about the system. The system is manufactured in various configurations, which together make up a family of stationary devices designed as laser-based cinematic firing ranges for conducting simulated firing from infantry weapons and weapon systems. The system's configurations include Snieznik 1, a device for conducting simulated fire on a multi-bay firing range; Snieznik 2, a device for conducting simulated fire on the battlefield; Snieznik 3, a device for conducting a simulated battle indoors or in the immediate vicinity of buildings; Mini Snieznik, a device for conducting simulated fire on a firing range and on the battlefield. This version is intended for users having rooms with only limited space at their disposal. A firing post simulator for marksmen. A firing post simulator for a 60mm light mortar. A firing post simulator for a 40mm automatic grenade launcher. A firing post simulator for a helicopter onboard gunner. Other devices which are presently being developed. Each of these installations consists of assemblies appropriately deployed within the training post. These assemblies include a central unit based on a set of PCs with the Windows operating system and specialized software, an operator's workstation equipped with devices for conducting and supervising exercises, an image projection system and a system for tracking aiming points on the screen, an audio system, a set of weapons simulators, the necessary equipment for device configuration. By means of realistic computer graphics, training situations are displayed by projection systems on a flat or cylindrical large format screen. In its basic version, this screen measures 12 meters in width by 3 meters in height. The actual image size is selected according to the configuration of the device, the dimensions of the room, the type of armament and firing post, and the user's requirements. Trainees conduct simulated fire from training weapons equipped with laser emitters while standing about 3 to 8 meters from the screen. Depending on the system's configuration and training needs, from 1 to 10 individuals at a time can train in the firing post. The virtual space of the exercises. Training situations are created on the basis of a three-dimensional computer model of a terrain whose surface area measures up to several dozen square kilometers, over which targets are moving and on which buildings and objects are deployed. Users are provided with several exercise areas representing different parts of the world and featuring diversified land formations and surface cover and the possibility of smooth changes of weather conditions such as fog, snow and rain. Training can take place at any time of day, thanks to which very realistic lighting conditions can be obtained. The device's operator, working with a map of the terrain model, arbitrarily matches firing posts to the place the exercise is being conducted in virtual space. He creates events according to training needs, using a database of three-dimensional terrain objects in combination with a set of software tools. Simulated fire is conducted on the basis of virtual bullets moving along ballistic trajectories that conform to that ammunition's trajectory in real life. These are determined in the three-dimensional space of the terrain model on the basis of the work of the weapon's aiming points tracking system on screen. The ballistics of the bullets corresponds to the various types of ammunition and weapon models. This also takes into account such environmental factors as side winds, the difference in height of the target and firing post, the type of propelling charge, the settings of detonators, etc. Firing can be conducted using tracer-type ammunition and silencers. Weapons simulators. The trainees conduct simulated fire from training weapons designed on the basis of real combat weapons, but which have been permanently set to be unable to fire live ammunition. However, they are so constructed to ensure the following: their functionality, basic dimensions, mass, and operation of the mechanisms found in the regular weapons. They are equipped with laser and electronic modules which are connected to an external weapons communication module. This controls the operation of the weapon simulator, supplies it with electricity, and communicates wirelessly with the system's central unit based on PC computers. Such a configuration ensures mobility of the simulators within range of the training device's firing posts. Part of the construction uses wired communication, which at the same time supplies electric power to the electronic modules. In order to make the operation of the simulators as realistic as possible, they use high-pressure pneumatic systems whose task is to enforce the movements of mechanisms imitating the operation of the weapons systems when firing. These systems are powered by CO2, which is loaded into containers placed in the magazine clips of the weapons. Several types of training weapons are equipped with pneumatic systems that are fed with air through a polyurethane tube from an external tank. The set of available weapons simulators covers a broad range of the weapons found in the Polish Army's arsenal. These include Glauberit machine pistols, rifles and automatic rifles, mini-barrel, AKM, AKMS, machine guns, UKM, 2000P, PKM, sniper rifles, SWD, TRG-22, Bor Alex, TOR, automatic and armor-piercing suspended grenade launchers, GPBO, Mark 19, RPG-7, LM-60D light mortar, M134 propelled rifle, military pistols. Within this system, it is also possible to use optical and optoelectronic gun sight simulators, which are designed and manufactured on the basis of the sub-assemblies found in the real devices. In these devices, technologically advanced solutions are used, including mechanisms for adjustment of gun sight reticles, illumination, image magnification, dioptric correction, and parallax error correction. The set of available simulators includes Smith & Bender's 3 to 12 by 50 PM2 LP optical sights, PCS-5 and PCS-5M night vision sights, CKW and CWKW day and night vision sights, the Leopold Mark IV observation and firing scope. The optic and optoelectronic gun sight simulators, together with the selected weapons simulators, make it possible to conduct training exercises in long-range firing, for instance, under various operations dynamics, specific terrain and lighting conditions, as well as training exercises in poor lighting conditions. Comprehensive battlefield simulation. Each of the devices from the Snieznik family, as well as other simulators manufactured by Autocomp Management, for instance TH1 type simulator for the gunner and commander of the Rosomak wheeled armoured vehicle or other weapons, can cooperate with other units within the same exercise space and comprising the components of the Spartan Comprehensive Battlefield Simulation System.